Check, check, check. Hey.
Hey.
Yeah, I'm from New Zealand, which means that it's actually 5 a.m. my current jet lag state. So this is going to be great. This would just be like, yeah, exactly. It'd be like at the club, we're just raving about like stuff. So I'm going to attempt to keep to my time limit, which is 25 to 30 minutes. And if I go over, then actually I'll probably fall asleep before then, so it should be fun. So I'm just going to get myself something to drink. This is the one-handed juggle thing. Okay, so this is the title of my talk. Is web audio ready for the dance floor? And I have been using web audio on the dance floor, so I'll let you decide at the end of this talk whether or not it really is ready for it, but ready or not, I am definitely using it. So, the last 3 years, I have been developing a DAW entirely made with web audio. It's specifically focused on playing live electronic music. So it's kind of like Ableton, but without the other view, without the session. So it's it's not without the arrangement view, just the session view, and without the loops. So it's just like, there's no loops to begin with. You have to record everything as you go. So you set up your sounds and then you just start playing. So I'm going to give you a quick demo, and it's going to be one of those awkward, I'm going to pick up the mic, talk, and then do some things, sort of demos. So this is my application that I have built, and if I come over here, I have MIDI hardware, a wonderful selection of Novation products. We have the launch control, and we have the Launchpad Mark II. So, to get started with Loop Drop, all I do is I set up the corresponding things for the hardware I have. So I've added a couple of launch pads, and I've added my launch control here. And then I've dropped some sounds on. So we've got a drum kit, which is just, kick and snare and stuff. And some bass. And other random sounds. So, I'm going to show you what it's like without explaining anything, like kind of what it can do. So, here goes. Oh, you can turn it up. This is the moment when I panic because So, I have a confession to make. I released my version 3 of LoopDrop about half an hour ago. And apparently, I broke something. But anyway, it's okay. So anyway, you kind of saw what I was doing until I pushed the button and nothing happened. Anyway, so LoopDrop is, as you can see, it plays sounds, but it also plays sounds perfectly in time with the beat. So we've got like manual, and then we've got beat repeat. And looping. So the idea is you can build up an entire track without having anything pre-recorded before you start. In fact, that's kind of one of the fundamental assumptions of the entire project, is that nothing pre-recorded, but you're just choosing which instruments you want to have on stage. So that is my app, and I'm going to get on with the meat. This is an integrated synthesizer. Web audio is not like this. It is nothing like this. Web audio is more like this, which is a modular synthesizer. So for anyone that's just starting to get their hands dirty with web audio, you might be a little overwhelmed because it seems like there's so many little pieces that don't really do very much on their own. But when you assemble them together, you can make some pretty amazing sounds. You can pretty much make any sound you like. And so I like to think of web audio as being the canvas of audio. So in the browser before we had canvas and SVG, you could only create things that were square or like maybe rounded. But with canvas and SVG, we can now make any shape, and we don't have to be using Photoshop to do all this stuff pre-rendered. So it's the same thing with web audio. We can create stuff on the fly without having to render it in something like Ableton or Logic. But when you're building something like LoopDrop, there's a lot of questions about how you're actually going to structure your app on top of the API, because there's so many different ways you could do it. I think most people, when they're starting out, you have some DOM elements with event handlers, and when you click those things, maybe you call .value vcalls on some nodes that you've set up beforehand. But as you start to create more and more complex things, you need to choose some abstractions that kind of scale out well and handle the various different browser incompatibilities and all sorts of exciting things like that. And there's a few really good libraries that have been made, like Tone.js and stuff like that. But I won't really talk about that. I'm just going to tell you about what I chose to do in LoopDrop, which is basically no libraries whatsoever, but I've built a system where LoopDrop is really just a JSON renderer. So it takes JSON files and displays them on your screen with a nice little bit of formatting. And it just so happens that those JSON files are specifying some pretty cool things. And I've written a little bit of code that can turn those JSON files into a nice interface and hook them up to the correct code to actually execute that. So project.json, that's what's loaded into the main window here. So LoopDrop doesn't actually know how, what's going to display until it looks at the main file and it goes, oh, the type of this is a project. And so it's going to look up and see if it can find something that can render a project. So these are all the different things LoopDrop can do. So it finds the project and it goes, oh, okay, how do I render this? And it's got some code that renders that project. And it also drops all those parameters, into the object. So it just injects all the parameters that are in the JSON file into this. So all of LoopDrop is just structured like this, and it's like very hierarchical, nested all the way down. So anything can be inside anything else, and so in that way it's kind of like a modular synthesizer where you can plug this into that, but the user interface itself is going to enforce some things that make more sense, like you can only put an oscillator inside of an audio channel and things like that. Well, that doesn't actually make sense, but that's the sort of example. So, you might think, actually, I was going to say, when I planned this, you might think that web audio is all like great and my demo, man, it looks so wonderful, except my demo didn't because I broke everything. But it's not. There are some big problems that I've faced, and I thought, since this is the web audio meetup, I might as well share some of the issues that I've kind of hit while trying to develop pretty like heavy-duty app on top of this API. So, here I am. This is the first gig I ever played to people that weren't a tech audience. And unfortunately, what you're about to see is very tragic. And happens a little too often for my liking at the moment. You can't do that to people. They're vibing out, they're having a great time. And then like, technology's getting in the way, they're reminded that this is all an illusion. This is not actually music. This is actually a web browser that can't even render stuff in time for the sound card to play it. So, the problem is that it's actually very difficult to debug these sorts of issues because web audio is a black box. So the API itself that you're seeing in JavaScript is very straightforward. It works like any other thing you'd use in JavaScript. But that's not actually the web audio there. Web audio is happening in a completely different thread in C++ land, I think. And all that you're actually doing from JavaScript is passing messages to this magical C++ land. And there's no way you can get any hooks into that other world. It's in a completely different thread. All you know is that it's using lots of CPU. And that it glitches out all the time. So, really, it's a lot of guesswork, and you kind of get to learn what doesn't work, but yeah. So I think this is like I'm just going to go through some like basically the things that get people when they're trying to build something big with web audio. The things that got me. So the first thing is the blocked scheduler. So you may have used some cool web audio demo or your own little project you're working on, and it's going great, and then you maybe switch to a different tab or start scrolling, or maybe your computer does something. And then like the beat just sort of like gets a bit behind, or like there's just some weird little like stutters. It just doesn't quite sound like a bad drummer, you know, just you can't quite keep time. And that's probably because you are just using a set interval and you're scheduling things as fast as the computer can play them, using like the same methods you'd use for doing any kind of animation in like a browser. But the problem is that audio is, instead of being only 60 frames per second, it's like 20,000 frames per second? 40, well then your hearing can't resolve that. But yeah, basically, the 40,000 is like the interlacing. It's just to kind of fill in the nonsense. But anyway, yeah, so basically, it means that within like milliseconds, like 2 milliseconds or something like that, you can hear that something isn't in time. So the ordinary JavaScript ways of scheduling things are just not good enough for audio. And so the first thing you can do is you can just start scheduling specific times for sounds to play. So you can say, I want to play this sound at this time, rather than, you know, trying to do it all at once. So you'd set up like basically a timer that ticks every second, and then it schedules all the things that are going to happen in the next second all at once. So that means that if anything happens in that little bit of time, you know, you can sort it out. But the problem is that adds a whole second between when you want something to play and when you actually hear it play. And in something like WebDrop, I need to be able to go, I want to play this now. So I've had to shift that window right down to about 20 milliseconds. And it means that if anything in the browser is going to take more than 20 milliseconds, like garbage collection or something like that, then it's going to glitch out. So really the lesson here is that you cannot garbage collect if you're doing like serious web audio stuff. And probably most people that are like have a more sort of DSP background are like, well, you just can't do audio stuff in JavaScript. That's stupid. It's got garbage collection. But because you've got the separate thread running, it's okay. But it's getting the messages to that other thread. And if something happens in between, I want this message to go to the other thread, it's just not going to get there. And what you're going to hear is nothing, which is not good. So I have basically had to drop all of the libraries from LoopDrop for this very reason, because none of them know how to manage my memory. So unless something has actually been explicitly optimized for just no garbage collection, you're going to have a bad time. Now, this is the next wonderful thing that I started encountering. So, did you see that picture I had before of this thing? The great thing about actual analog synthesizers is you have no CPU limit except for maybe quantum physics or something. Like it's pretty much, there is no limit. You plug in more devices, you get more power, you can do more stuff. Whereas with web audio, it's all going to run on your CPU. And so as you add more and more things, your CPU is going to do more and more stuff. And you don't necessarily think about, when you're just adding more and more nodes, how much CPU this is actually going to use. So before long, you just start like dropping, like it just starts getting really slow, and you don't really know what it is that's actually using the CPU. So the best thing to do is just to make sure you're always tracking every node that's actually playing something all the time, and come up with all sorts of crazy hacks to only actually be having things running or connected to the graph that are actually things you want people to hear at that time. And you also have to watch out for things like LFOs and clever params. You want to like add different signals together, because all that stuff is really, really expensive. So if you can do things just by using audio params, just setting them directly, they're going to be way, way faster than if you try and use like a constant source node and run that into something else. It's going to, if you try and do it the modular way, you're probably going to have a bad time. You're going to do lots of nasty hacks to actually get the performance you need. And it turns out there's a great big bug in Chrome right now, that if you disconnect an audio node before stopping it, it will never, ever, ever garbage collect. Never. And the best part is, if you lose reference to that node, it's gone, but it's still there. It's still on your heap profile. If you go in there, it's in there, and there's nothing you can do. It's just there forever. And the only way to make it go away is, before you throw it away, make sure it's connected to something and then stop it. And then it's okay. But that's been haunting me for the last 2 years. I only just figured it out yesterday. and so what happens is, like, first 10 minutes, 20 minutes, everything's fine. And then as you're playing for longer and longer, just stuff gets a little bit kind of glitchy. Like, you try and drop that really cool bass line and it drops, and you're like, what's going on there? And so you close everything, and you look at CPU and it's still high, and you're like, what? But that's what it was. That's what it was. Anyway, I'm a bit mad about that. But anyway, okay, all right. Okay, we're getting into, this is, hang on, 5:52 a.m.? Yeah. We're nearly into awake time again, that's good. So, this is another fun issue, is that everything is changing all the time with web audio. And so, each release, things break. And you go, oh, I can fix that. And so you go through and you fix all the things. In the next version, you got some weird bugs, and you're like, that's weird, what's that from? And it's actually from your fix you did last time. And you're like, well, you don't even think to check that, because you're like, oh, okay, it must be some other new thing. But no, it's actually like, if you just made your code how it used to be, then it will start working again. So that's kind of fun. And that's one of the main reasons that I'm developing LoopDrop on top of Electron, because if I wasn't, I think I would actually go insane. But this is going to get much better in the future, I think. It's just that right now, the team have got very focused on really getting the performance good. But in the process, they've made some optimizations that are breaking things that they just don't have tests for. So, yeah. Speaking of testing, No wonder that they don't have like tests, because it's really, really difficult to test audio stuff. And do you want to know how I test loop drop? This is how I test loop drop. So this is a performance test, just seeing like, you know, how many simultaneous nodes we can play at once. That didn't used to drop there, I must have broken something. So the idea is if it can sustain that for 10 minutes, it's ready to ship. I would really, really, really love to see some like clever hacks around actually good audio testing. So if anyone's got some interesting things that they've done with web audio, I'd love to hear about it for testing. So, the future. So, like I said, as of probably 40 minutes ago, I just released version 3 of Loop Drop, which I've been working on for the past 9 months. I haven't released anything for 9 months. It's just been like, I've been pushing to GitHub, but I haven't actually released any new versions. And that's because I've been doing this massive rewrite where I've been replacing all the libraries with like custom hand-rolled stuff that doesn't do garbage collection. So, yeah, I just pushed it up. Like, I gotta get this thing out, but apparently it's broken, so don't download it yet. And I don't know if people have heard of this thing called audio worklet. I've heard of it, like, 3 years ago. And then I heard of it again 2 years ago. And then 1 year ago? No, not quite that bad, but I think it was 2 years ago it was first announced, and it was called something different. We keep hearing about it, and apparently it's going to let us finally solve all the problems in the world. But it's not here yet, and it's probably never, not even going to be that great anyway. So I'm trying not to call out for that, but I'm so looking forward to it. So for those people who haven't been following along with the audio worklet, it's a way of executing JavaScript directly on the audio thread. So at the moment, with web audio, you're only ever constructing instructions to be executed by the actual C++ code, which is playing your audio. So you can't just do some custom like code to generate sound. You've got to actually create it using like the API they provide to you. Unless you use the thing called the script processor node, but that's actually just a callback that's running like with about 10 milliseconds latency latency and then sometimes that will drop out, and it's just a horrible situation. But this is actually going to let you run JavaScript in a completely separate audio thread, and it might be great. So, web audio might not be quite ready for the dance floor, but I think that it's ready for tech conference parties. So this is it in Singapore in November. He was there. Anyone else? Oops. So we've got lighting completely powered by HTML and CSS. And we've got music powered by JavaScript. And we've got visuals, which are actually, it's a VJ software that mixes div elements together. And you're going to hear all about that at the conference if you're coming. Ruth will be talking about that. So that's all I've got, but I'm pretty keen to answer anyone's questions if you've got anything. Sorry, I kind of skimmed through a lot of stuff there. I thought I'm not going to try and do anything complicated. I'm just going to rant about my experience, because that's what I've got right now. But yeah, I hope you enjoyed it. Can I ask, can people ask questions? Is there time for that? Okay, sweet. So anyone got any questions?
Thank you for your talk and the performance. I have a question, maybe it would be silly, but maybe About these obstacles with performance, can web workers help us in this or not?
It depends what the problem is. If you're trying to do real-time stuff, then web workers can't really help you. If it's stuff that you can wait for, then yes. But the problem is getting from the web worker to your sound card, to your audio hardware, it needs to be in a really direct route. You can't do it in a separate thread. So what you're talking about can be done now, but it's not very good. And that's what the audio worklet is all about doing, is giving you the web worker type experience, but directly in the same thread as the actual audio. Does that answer your question?
Yeah, but maybe, so, related question, did you try it, or did you try use web workers for this?
I haven't tried because I can't deal with like more than about 10 milliseconds of latency, and I wouldn't be able to get that.
Yeah, thank you.
Hey Matt.
Hey.
What's up? So I had a personal question. So for you, did you start out more as a programmer engineer, or were you first into music and then decided to, pursue that? I mean, which one came first, or were they simultaneous? And what kind of led you to kind of build this programming, or were you always doing, little programs, this and that, and then, I kind of want to know the background and all that.
Right. I don't think I knew anything about programming until I really started working on this project.
Mm-hmm. Oh wow! That's
I mean, I thought I did, but
that's inspiring. Yeah.
Yeah. Basically, this has been my big learning project. I'd done website stuff before that, but nothing like
Java and
like Ruby and like some front-end JavaScript
okay,
stuff.
Yeah.
So it's all like related. And the reason that I started working on this project in JavaScript is because I already had some experience with JavaScript. Originally, this started out as a little script that I was running inside of Ableton Live. So it was like a little Python script. But then I quite quickly hit some limitations and then ended up rewriting it in Node.js. So what I was doing is I was sending the messages from my MIDI controllers to a magical Node.js script, and then forwarding it onto Ableton Live, so I could like do plenty of transforms in JavaScript. And so that's where all of the stuff that you see, all the stuff that you saw happening on these pads with the way that the looping works and then the way the controls work. I did all that like about 3 years ago before I started on any of this web audio stuff. And then I don't know. I don't really know why I do the stuff I do.
No, I mean, it's basically you thought you confronted a problem, and because you didn't find a proper solution, you created your own. So
Yeah.
that's why I wanted to ask if you're essentially like a programmer engineer at heart, because then that's different. Then that's just crazy, and you just want to do that all the time. But if you essentially did not have that background, that's
No.
great. Cheers to you.
I'm a hobbyist entirely. So. Oh,
yeah,
there's
great.
one down the front here. So.
Thank you.
Yeah.
I have a loud voice. I don't know.
Okay, let's get back.
So you were talking a little bit about scheduling and a clock. Are you still using just callbacks and then set timeouts for that right now?
So I have a really fast set timeout running. I'm using the web worker hack where you have the set timeout, the set interval running on a separate thread, and it's posting messages to your window, and that's running at like, I don't know, every 10 milliseconds or so, and then that schedules little windows of time about 20 milliseconds ahead, which means so it can get a little bit behind, it can miss the odd tick, and it will still catch up. So it's just kind of running in a bit of an organic way where it just sort of floats around a bit, but because we're staying like 40 milliseconds ahead or so, so I'm using all like, when I actually schedule nodes, I'm specifying the exact time in audio space I want to hear them. But I'm scheduling those only milliseconds before you actually hear them. Does that make sense?
Yep. And then just as a quick follow-up, do you feel more limited by the single thread or by the resolution of time? Because like with millisecond resolution, it's pretty hard to do like real sample accuracy. So would explicitly would a nanosecond accurate time object in JavaScript help at all, or is that tangential?
I don't think it would really help, because the thing about JavaScript itself is that you can't expect millisecond accuracy from it anyway. Just like a random allocation could block for 20 milliseconds, you don't know. So not really. I think the way that they've handled the API is really good, where you just have to think in a separate set of time coordinates, and you just kind of like chasing after, or chasing slightly, the sound card is chasing behind you, and you just gotta like run slightly ahead of it and drop the samples for it, like laying down tracks for it. That's how it feels. I like that analogy, thanks for that.
Well, what's the buffer size you're using for this?
It's hard to say because Web Audio itself uses a 128 sample buffer for everything it does, but that doesn't really expose that to you. All you've got is a timer ticking up from like amount of fractional seconds since you first created the Web Audio context, and then you just specify in decimal points of seconds when you want to hear things. So there's no real, like, the samples aren't really anything they expose in the API, if that makes sense.
But can you somehow increase the buffer size? I mean, I would just create kind of a circular buffer and somehow increase this into...
Right.
Because if you are saying it's 20 milliseconds, that's around 1024 samples.
Yes.
So I think it's okay with 2048. I think it's still, 40 milliseconds would be.
I see what you're saying. I think it is more like 40 milliseconds that I'm actually, that I have. But the point is that it needs to be as low as absolutely possible.
Yeah, but 40 milliseconds is really tiny. I don't know.
Oh, maybe at like 60 milliseconds. 60 beats per minute. Once you start getting up to 140 or like 200, I don't know. That's like half your beat. It's gone.
Yeah. Well, I guess it depends what you sacrifice. If you want.
No, the thing is that I could make it whatever I want. I can just tune it. It's like a really easy parameter for me to change, and I've pulled it down as far as I can where my computer doesn't garbage clip that long. That's basically the limitation I've got. But yeah, thanks for the tip. Is that time?
Yeah,
Cool.
maybe one last question.
Yeah.
So you mentioned that you try to minify the work of garbage collector. How did you do that?
So there's a few things you can do. The first thing is just make sure that things are actually being released correctly. It's quite easy to have stuff lying around that isn't being released. And as your heap gets bigger and bigger and bigger and bigger and bigger, garbage collection gets slower and slower and slower and slower. So if you just keep your heap right down like it's sort of 20 megabyte size, things just run beautifully. So that's the first tip. And the second tip is there are things you can do that just avoid the garbage collector altogether. For instance, if you don't actually save it outside the scope of the current function, instead you just throw it away as soon as that tick finishes, that's going to just skip the garbage collector. It's just going to get thrown away automatically. Well, not quite, but for all intents and purposes. So I had to stop using virtual DOM because virtual DOM caches between frames, like caches your entire DOM, and it's throwing that away all the time because it's like immutable and stuff. And that was causing quite a lot of GC, what do they call that? Thrashing, I think. So I switched to use an approach that's a lot more like the old-fashioned way of manipulating the DOM, where you target individual elements. But I'm using basically like two-way data binding. It's like ASP.NET. It's great.